Hi. So today I'm going to be discussing about the instantaneous rate of change formula from the preceding slide. To start with, you need to get a graph that has a curve where you can find a tangent. Now, to find the slope of the tangent, the formula is f into bracket a plus h close bracket minus f into bracket a over h. Now this formula is used to find the slope of the secant. Now you find the slope of the secant, and when you find the slope of the secant, you put in this value of the slope of the secant into another formula called y into bracket y equals to mx plus b, and that is to find the slope of the tangent, the point where the tangent just crosses just a point on the graph. Now using these two formulas, we can get this and we can get this. Now the slope of the tangents is this blue line here, if you can see. Okay, so the slope of the tangent is this blue line here. This is the blue line for the formula y equals to mx plus b, and here is the slope. This is the slope of the secant here, and this is your slope of the secant. Now why are these things used to understand the instantaneous rate of change formula from the preceding side? Obviously, because we're doing from the preceding side, we have to take values of h that are below your normal value, because I am using a point at 3, so I have to pick a point before 3. So you pick, because you're doing preceding, so you're coming from behind. So this is, you have to pick a point at the side. Now these points are the main points in which we're going to use to explain the instantaneous rate of change from the preceding side. Now in our former class, we learned that the slope of the secant becomes becomes this from the real formula f into bracket a plus h close bracket minus f into bracket a over a plus h minus a, but the a's cancel out, so leaving h this. So it is said that the slope of the tangent at this point would be when this point approaches this. And finally, to make it shows that this value is always positive. Now we can check it from here. Now as this point, because we're going to do from the preceding side, so as this your h, as your h value reduces, your value tends to shift towards the slope of the tangents, hereby making your slope of the secant smaller and smaller. Now the reason for this becoming smaller and smaller is because the preceding values were in which we're picking to find the slope of the secant are becoming smaller. So as your h tends to move towards 0, your slope of the secant also tends to become smaller and smaller and smaller, until a point where your slope of the secant will overlap and become a slope of the tangent, and at that point, that is where your value becomes undefined. So let's put in 0. So we can see at 0 there's barely no difference between the slope of the secant and the slope of the tangent. And if you can see here, this point here is undefined. Your Desmos helps you to find out like without using your calculator. You just put in your values, so it shows that this is undefined. So it shows that is why when solving the IRC, the m is equals to lim, as h tends to move to 0. Hereby h is not equals to 0, h moves towards 0. So your h is not meant to be 0, because when it becomes 0 it becomes undefined. So that's why we do not use exact. That is why when you use 0, it becomes the slope of the tangent. So to remain the slope of the secant, it has to tend to move to 0, but because this is the preceding side, it's moving to 0 from the left hand side. But if we're looking at a general case for the instantaneous rate of change, it moves from both sides, but this is from the preceding side, so just the left side. Also in our class, it also explains to us that this slope of the tangent and slope of the secant are actually very close, because when you check it through Desmos allows us to view how and when the h value reduces and how it moves towards the slope of the secant. In this point, I would say technology is very helpful for us, because now let's say, like with technology now, if I play it, I will be able to see how my line moves according to how it's meant to move. So this is, look, as you can see, so let's see, you can see the slope of the secant is becoming larger and larger because it's moving away from 0, but as it moves closer to 0 it becomes very small to the point where there is no more slope of the secant and it becomes the slope of the tangent. Now and in conclusion, I will just try to end up with the slope of the secant and the slope of the tangent are very closely related, that can be mixed up easily. So I would say we shouldn't mix them up. Thank you. You've got a hold of me, don't even know you.